Yes, how are you?
We are fine, fine.
Okay, where are Kina Jennifer?
They are joining, I guess. They are joining already.
Okay, thank you. It has been so long since we met the other week. So today also I want us to revise on chemistry. I'll just only take 40 minutes so that we finish it as early as possible because I have some commitments. Sawa sawa. So let us proceed as we wait for others. They will get us on the way. So let us revise this topic, that is simple classification of substances, and let us get something at the end of it. So these are the possible questions that you can ask from this topic. And I urge you to be very careful, and you be very vigilant on whatever we are going to do, so that at least you understand wherever we are going to discuss tonight. From this, the first thing that you can be asked is to define the term mixture. So a mixture, from the the layman language, that maybe a mixture is a combination of two or more substances placed together. That is all. Maybe if you want to prepare maybe rice, you will be maybe separating the rice from the stones, such like things. So to me, before you separated them, it was a mixture of the stone and rice. So that is from the layman language, that maybe, But according to chemistry, a mixture is a combination of two or more substances in which the individual component forming a mixture retain their physical and chemical properties. So for you to earn the complete marks in Form 1, they usually give, they always give 1 mark, no, 2 marks for this. So you have to know that very well. So this is what you have to know very well, that a mixture is a combination of two or more substances in which the individual components forming the mixture retain their physical and chemical properties. So, like for example, if we talk about the iron filings, if there are a mixture of iron filings and maybe uh, the mixture of iron filings and maybe iodine. So you know the properties of the iron filings. To me, they can be attracted by a magnet. But the iodine undergoes a chemical process, that is, it sublimes. So to me, the components forming the mixture, the two mixtures will now they will retain their physical and chemical properties. Like I've said, that the iron filings will retain their physical properties of being magnetic material, and also the iodine will retain their chemical properties of being the sublime. So that is what you have to know. So when you are asked to define the term mixture, you will say it is a combination of two or more substances, and the individual in which the individual retains their physical and chemical properties. Or somebody can say it is a substance that consists of two or more elements or compounds that are not chemically combined. So they are not chemically combined. So that is also how we can define mixture. You can say it is a substance that consists of two or more elements or compounds that are chemically combined. Then we have also another term which is very common, that is sublimation. Sublimation you did even in primary. So a sublimation is now the process by which a substance changes from solid to gas or gas to solid directly without forming water or without forming liquid. So the that is the sublimation. So it is a process by which a substance changes from solid to gas or gas to solid without forming liquid. Are we together? Are we together?
Yes, sir.
Yeah, you have to respond for me to know that we are together. Then there is another term which is very, very magnetic. That is saturated solution. For those who are doing salt in Form 4, maybe if you reach in Form 4, there is this topic called salt. You'll also learn about the saturation. Also in Form 2, under salts, you learned about the saturation. In Form 1, under simple classification of substances, you learned about the saturation. So you can be asked to define a saturated solution. So a saturated solution is a solution that cannot dissolve any more solute at a given temperature. So it is a solution that cannot dissolve any more solute at a given temperature. That is a saturated solution. You should know that very well. Uh, we have also crystallization. So crystallization is just the process of obtaining crystals from a saturated solution. So that is that. It is a process of obtaining crystals from a saturated solution. Then we now have these crystals, the crystals that we'll obtain from a saturated solution. Now, what is this crystal? So crystal is a solid with a definite regular shape. Like sugar crystal, we have salt crystals, we have also maybe crystals of maybe sodium, not sodium, but lead nitrate crystals, such like things. Also, we have we call them the oxalic acid crystals. You know, the oxalic acid, they are in solid form, and most so they are in crystals form. So that is that, and you should be able to know that. So a crystal, just the way I've said, a crystal is a solid with definite. Definite to mean you can define its shape. You can be able to explain how it looks like, the appearance of the shape of that solid. So it is a solid with definite regular shape. So that is how we can define the term crystal. Then also we have another question that says state and explain two types of mixtures. We have two types of mixtures. We have homogeneous mixture and also we have heterogeneous. So what is homogeneous? Homogeneous mixture is a mixture with a uniform composition and properties throughout its mass. To mean it is a mixture that forms one layer. For example of a homogeneous mixture is water and milk. Water and milk form homogeneous mixture. To mean they form one layer. That is, they form one layer. And also we have the opposite of homogeneous, it is heterogeneous. So heterogeneous now, it forms more than one layer. For example, paraffin and water. If you check paraffin and water, they will not form one layer, but they will form two layers, where the more dense will be at the bottom and less dense will be at the top. So make sure you know that heterogeneous is a mixture without uniform composition throughout its mass. So that is it. You should be able to know that, and how to separate the heterogeneous mixture. Maybe they're usually in terms of liquid. How to separate them? Usually use maybe the filter. We can use the dropper. We can also use the separating funnel, the separating the heterogeneous kind of mixture. Then let us continue. Then another question is, define the following terms as used in the mixture. Residue. So what is a residue? A residue is a solid that remains on the filter paper during the filtration. So maybe, for example, when we are using the filter funnel, uh, let us assume this is our filter funnel. We are assuming the what I'm drawing on the screen is the filter funnel. Then inside the filter funnel, there is a filter paper. The filter paper. In this filter paper, maybe we were separating a mixture of water and sand. So when we pour water, that mixture here, the sand will be here, will be trapped by this filter paper. They will not pass through the filter paper, and the liquid now will pass and will be collected maybe through a beaker or a conical flask, whichever the case. Then whatever will remain on this filter paper, this is what we call the residue. So they cannot be able to pass through the filter paper. But the liquid which will pass through the filter paper is now what we call the filtrate. So the filtrate will now pass through the filter paper. Then also we have, I've talked about the filtrate, so there is no need of repeating it again. Let us now see the solute. The solute. Solute is a solid that dissolves in a particular liquid. For example, when you have water and salt, when you put salt crystals inside the liquid, which is water, it will dissolve to form a salt solution. So the solute is now the salt that now dissolves in water. So how can you now define the term solute? Just the way we have said, it is a solid, it is a solid substance that dissolves or that can dissolve in a particular liquid. You should be able to know that very, very, very well. Then again, uh, we have also the solvent. Now the solvent is now that liquid that will dissolve the solute. For example, in our case, we had salt and water. So water is now the solvent. So it dissolves the solute, which is salt. So to me, the salt, no, actually the solute plus the solvent give us now the solution. So when you ask the solution, so solution is a liquid which is a resultant of a solute and a solvent. You should be able to know that. So for example, in our case, where we had salt and water, so the solution is now salt solution. Solution. I think, are we together there?
Yes.
Uh, Let's proceed another term. I want you to understand these terms before maybe we go to the actual. This term will help you up to the form 4. We have also miscible liquids. So the miscible liquids are liquids that can mix together to form one layer. For example, ethanol and water. That is miscible liquid mixture. Liquid that can mix together completely. So that is miscible liquid forming one layer. Water and milk, that is miscible liquid. Immiscible liquids are now liquids that cannot mix completely. Instead, they will form more than one layer. For example, paraffin and water. Who can give us another example of immiscible liquids?
Water and kerosene.
Water and kerosene. Another person?
Paraffin and a cooking fat.
Sorry?
Paraffin and a cooking fat.
Paraffin and cooking fat. Okay, because what can make those things not to mix together is now the densities. They have different densities. So we'll be able to discuss those later in the next slide. So now check on the next slide. State 3 physical means that can be used to separate a mixture. Physical means. One, we can use winnowing. I know you know what is meant by the term winnowing. We can sieve. I know you know sieving because huwa mnakunywa chai, you usually sieve before you take it. You can even sieve water, such like thing. Also, we have filtering. When we have filter, you should know the difference between sieving and filtering. That is filtration. You should be able to know that. We can also separate them by evaporating, decanting, and the use of a magnet. So these are examples of physical means that can be used to separate a mixture. Then there is another question here. Study the setup shown below and answer the questions that follow. You can study it. We have this part, which is part A. We have part B. We have part C. We have also part D. We have part E. We have also part F. We have now part G. So now the first question, you are asked to name the parts marked A, B, C, D, E, F, and G. So the first one is A. A is now the beaker. Then B is now the glass rod. So this glass rod is what helps this beaker not to lean on the filter funnel. Then we have C. C is now the filter funnel. Filter funnel. In exam, don't write funnel because we have so many different of funnels. We have pistol funnel, we have separating funnel, we have this filter funnel. So you have to, you must be specific. If you just write funnel, you'll be marked wrong. So you write the filter funnel. Why do we say it filter funnel? Because of this filter paper. So you should be aware of that. Then we have this D. So the D is the one which is inside here, this one. So this D is now the filter paper, the filter paper. So the filter paper is used, it is like, it has some pores, those small holes that are not visible, that will allow the filtrate to pass through it, but it won't allow the residue to pass through it. Then also we have this E, this part E, that is the conical flask. It points at this apparatus here, which is a conical flask. Then we have this F. The F is now that liquid that passes through what? Through the filter paper. And you can see it was a mixture of water and sand. To mean this one will be water, which is another way we have said it is a filtrate. We said the filtrate is now the liquid that passes through the filter paper, of which you should be able to know that. Then we have also part G. Part G is now the residue, the sand, which won't pass through the filter paper. So you should be able to know that. Then we have another question that says that name the above method of separation. This method of separation, we call it filtration. Why? Because we are using the filter paper and the filter funnel. That is why it is called the filtration. Filtration. Why is it possible to separate the above mixture using the method named above? One, we are using this method because here the mixture is immiscible. That is immiscible mixture of solid to liquid. So you should be able to know that, where the solid will remain on the filter paper and the liquid will pass through the filter paper. So that is what you should be able to know. Then another question is that state the suitable method that can be used to separate the following mixtures. Let us see those mixtures. We have ethanol and water. Ethanol and water, we use what is called fractional distillation. We use what we call the fractional distillation. Why? Because they have different but close boiling points. So that is why, yes, they have close but different boiling points. That is why we use fractional distillation, where we have sun and paraffin. If you check sun and paraffin, those are immiscible solid to liquid mixture. So we can use filtration. To filter, where we said that the sand will remain on the filter paper, it won't pass, but the paraffin will pass through the filter paper and will be collected as the filtrate. But if you go back here in ethanol and water, this is immiscible liquid. So here we use fractional distillation because the fractional distillation is used to separate miscible liquids that have different but close boiling points. Another one, we have sand and aluminum chloride. Sand and aluminum chloride. All of them are solid. They are solid. So if both of them are solid, now know their physical and chemical properties, just the way I said earlier. So you realize that aluminum chloride sublimes. So it undergoes sublimation. So the best method that we can use is sublimation, because it sublimes. It sublimes. It sublimes. Very magnetic. Then also we have another one, oil from nuts and seeds. Oil from nuts and seeds. This is now what we use, what is called solvent extraction, where what you will do, you will crush nuts and seeds, after which you'll add the suitable solvent, where you can use the acetone, you can use the propanol, you can use any suitable organic solvent. After that, uh, from there you will now filter. Then now you leave the filtrate on sand. The reason why it is left on sand, not on sand but sand, for the solvent to evaporate. So you should know that. Then also we have iron and sulfur. Both of them are solid. So check their properties. You will realize that the iron can be attracted by magnet. So therefore we'll use a magnet. Then also we have red and blue coloring pigments. All coloring pigments are separated by this method called chromatography. So the chromatography is used to separate the red and blue coloring pigments or coloring pigments, the spots. That is what should be able to know. Then we have another one, which is sodium chloride and water. Sodium chloride and water, they will form sodium chloride solution. So how can we separate them? Here we'll use a simple distillation, or we can use evaporation method. So the best one is simple distillation. That is one that you are advised to use. Then also we have another one here, that is petroleum from crude oil. Petroleum from crude oil, we use what is called fractional distillation. So fractional distillation is a method which is used to separate, which can be used to separate or to obtain. Here we don't separate, but we obtain the petroleum from crude oil. So if you go to maybe Changamwe refinery, you'll be able to see how this can be done. So you can organize with your teachers one day, you come and pay as a visit in Mombasa so that you can be taken here, you see how it works. So another question is, explain how you would obtain pure ammonium chloride from a mixture of lead sulfate and ammonium chloride. So a mixture of lead sulfate and ammonium chloride. So what you have to know that ammonium chloride undergoes what is called sublimation. So how can you now explain the process until now you separate the two? One, you will say place the mixture into a beaker and cover it with a watch glass containing cold water, where this cold water will now cool the vapor of the ammonium chloride. Then heat the mixture gently. Ammonium chloride will undergo thermal dissociation to form ammonia and hydrogen chloride. Ammonia and hydrogen chloride recombined to form ammonium chloride, which is collected on the cooler part of the watch glass. I hope I'm very clear there.
Yes.
Yes, I have 4 minutes. Then another question is that sodium chloride is contaminated with copper 2 oxide. Explain how pure sodium chloride can be obtained from a mixture. Sodium chloride is just the normal salt that you are using at home, the table salt. So how can you separate the two? That is, know the characteristic. I told you earlier that a mixture retains their physical and chemical properties. So know their properties. Like you will realize that copper 2 oxide is solid. Sodium chloride also is a solid that can dissolve in a liquid. So what do you do? If there is one that can dissolve in liquid, so the first thing that you should be doing, add water to the mixture and add water to the mixture to dissolve copper, that is the sodium chloride. Stir and filter to obtain copper 2 oxide, because copper 2 oxide cannot dissolve in oil in water. So you filter to obtain copper 2 oxide as a residue. Now you'll be remaining with the sodium chloride solution. That is a solution of sodium chloride and water. So what do you do for us to obtain the sodium chloride crystals? You evaporate the filtrate, which is sodium chloride solution, to dryness to recover the sodium chloride crystals. I hope I'm very clear there. Yes, I have 2 minutes. Let us proceed to the next slide. So you can see this. The diagram below shows the relationship between the physical states of matter. Now study it and answer the questions that follow. Identify the process R, V, U, W, and X. So study it very keen. Then we'll be able to answer the questions. So now the process R. The process R is from solid to liquid. So solid to liquid is melting, where the heating will take place. For solid to turn to liquid, there must be heat. So that heat will make it now to melt and form liquid. Then we have V. We have V, which is liquid to gas. Liquid to gas is evaporation or vaporization. So evaporation is also known as vaporization. So it is the process by now liquid changing to gas or vapor. That is very magnetic. Then we have the U, the part U, which is from liquid to solid. Now it is going back. For something to turn from liquid to solid, there must be cooling. And that is now what is called freezing, or it is called solidification. So solidification is the process by which liquid turns to solid. Then also we have the W, the part W, where gas turns to liquid. For it to turn to liquid, it will condense. So that process is called condensation. The process is called condensation. Then also we have the X, from gas to solid. That is what we call the deposition. So the deposition is the process by which a gas or vapor turns to solid. But sublimation is now the process S, which is from solid to gas. You should be able to know that. I've passed with 1 minute. I'll be able to, let me just finish up this, then we can call it a day. We will be just continue. I'll revise this all book 1, then I'll be able to go to Form 2 and Form 3 for you to gain something during this pandemic. Let's proceed on and check what is next here. Then here you can check very well. I've given mnemonic. So mnemonic is just the way of mastering this process. I'd given this mnemonic that reads sommelier colifreso. Sommelier colifreso. That is from solid to liquid is melting. Then from liquid to gas is evaporation. Then from gas to liquid is condensation. Then from liquid to solid is freezing. So that is mnemonic way of mastering there is a process, the physical states of matter. You should be able to know that. Then the last question that we are discussing tonight is you state two substances which can undergoes the process represented by S and X. So that is sublimation and deposition, but we usually refer it to sublimation. So the substances that undergo sublimations are things like benzoic acid, aluminum chloride, dry ice, camphor, anhydrous ion 3 chloride. So those are some of the substances that undergoes sublimation. Also, these have given it a mnemonic way of mastering these substances, that is Badika. So if you can use Badika, you'll be able to master these substances that undergoes sublimation. Badika, B stand for benzoic acid, A stand for aluminum chloride, D stand for dry ice, and dry ice is also known as solid carbon dioxide. Then I stand for iodine. Then C stand for camphor. Then A stand for anhydrous ion 3 chloride. Are we together?
Yes.
Yes. Now, when it comes to an exam, when you're asking, answering such a question, try to ignore things like aluminum chloride. Try to ignore some things like anhydrous ion 2, ion 3 chloride. You can use benzoic acid. You can use dry ice, which is a solid carbon dioxide. You can also use the iodine. You can also use the camphor. I know in exam you can be asked maybe two, not more than four. So the Badika will help you to master those substances that undergoes sublimation. I beg to stop from there today, then tomorrow or another day we'll be able to continue until we finish this. After finishing this, we will be able to go to another topic, which is acid base and indicators. You can also buy a copy of this book. It can assist you more so to revise in revision in Form 1 work. I'll be able to sell it in soft copy where you can read it via your laptop or your smartphone or the smart TV. Those who have the smart TV, you can also read this via the smart TV. Otherwise, why can't God bless you unless you have a question that maybe is hitting your back or reaching your stomach so that we can demystify it before we retire to our beds.
Teacher, why we should avoid aluminum chloride or anhydrous ion 3 chloride?
Yes, so the reason why we should avoid them, one, not all of them undergoes the sublimation. There are some compounds. If you are to involve them, you must use the word anhydrous. Anhydrous, but the neck rejected them, so that is why I'm also trying to help you out because you might be marked wrong for no good reason. Yes. Another question, if there is.
It's good.
Okay. So no question.
Yes.
Or if there is no question, let us end it from there. Then we shall continue. I hope it was good, and you can enjoy it next time. Huh?
Yes.
Yes.
Yes. The other two girls did not. The three girls